Hello there guys, welcome back to another tutorial. Up to the Time presents Epi-cycloid Construction today. Today we'll be looking at solving this problem here. So maximize the screen. And we are looking at plotting this rolling circle, which is radius 20 millimeters, as it rolls on the base circle, which is 95 millimeters. Now we are going to orient this at 60-degree angle. So the rolling circle is going to start at 60 degree and we're going to plot the curve that it makes. So the curve that it makes as this circle moves from 60 degree and it rolls across from left to right, this base circle that is 95 millimeter radius is going to create a curve called an epicycloid. And that is what we are going to plot today. So we have all our information here. So let me just set up this configuration here. Now you will see above here in yellow a formula. The formula for finding the angle. And we need to create an angle. We need to create an angle that this circle is going to roll on, because we cannot find the circumference of the path of this rolling circle. So we need to open up our compass to a certain angle, and the angle is 75.78. And how is this angle broken down? So the point that I'm looking for, I'm just going to use some annotations to actually draw where I'm actually searching. I'm actually searching for an angle between here and somewhere around here. So that is what I'm looking for, that angle in between there and the red. Let me just do that somewhere between there. That's the angle that I'm looking for. So I've used the symbol, the omega symbol, to determine what's that distance. So the distance between these two red lines, which has created an upside down A, that is the angle that I have to place my 75.78 degrees, so that would equate to the distance of the circumference if this were a straight line. But it's not a straight line, it's a curved line. So we're rolling this rolling circle at 20 millimeters radius along a path of 95 millimeter radius, which is called, the path is called the base circle. And yeah, so I think I've explained that as good as I can. I'm going to clear the drawing now from these marks, and I'm going to go straight into AutoCAD and start setting up this configuration. So the first thing I'm going to do is I'm going to create, let me see which layer I'm on. I'm on my construction layer, turn on my ortho, which is my F8, and I'm going to draw a baseline. At my baseline, I'm just going to come here at this point and I'm going to create my 60-degree line. Okay, so it's created 60 degrees to the right hand side, but I want my 60 degrees to the left. No problem, I'm going to mirror. Use the shortcut MI enter to activate the mirror command. So mirror that, and they ask me, do I want to erase my source object? Yes. So I just want the mirror object remaining. Now, I'm going to birth a circle somewhere here. It's a good point to birth the circle at the tip. And I'm going to open up my circle radius 20. So that's my circle radius 20. And now I'm going to come here and open up to my circle, which is my rolling circle, which is going to be radius 95. Okay, so obviously my radius 20 circle is not connected to my radius 95 circle. That's not a problem. I'm going to move them. And I'm going to snap at this point here and bring it down to this intersection. Perfect. So that's how I've gotten my rolling circle to touch my base circle. And the angle that I've used here is 60 degrees, right? So this angle in between here is 60 degrees. So I'm just going to put that information in now. I'm going to place my 60 degrees, 60 degrees, symbol for degrees. Cool. And this This is my rolling circle, sorry, which is up here, and my base circle. Now, this is where the formula comes in. I need to create a 75-degree angle starting here. So this is basically my 0. I need to create a 75-degree angle. That can be fairly challenging. So the best thing to do is to create the 75.78 degrees on the outside and then just slot it in there. That's what I'm going to do. So I'm just going to create my 75.78 degrees, right? And that's that angle there. And what I'm going to do is just make it a block. I call that angle. I mean, there are many ways to do this. I'm just doing the easiest thing. That's a block there. And I'm going to move my block now. M to move. That's a shortcut. And put it in position there. Now I'm going to, nope, it didn't snap in. So I'm going to snap it there. Still didn't snap in. Don't know what's happening. Endpoint. Intersection. Good. So that's all nice. Now I'm going to rotate this block. I'm going to rotate, specify my base point. Now they ask me for a copy or a reference. I'm going to touch R to reference, and I'm going to reference the angle that I have here. Okay, so I've referenced this round. So let me go rotate again. Into reference. Cool. Okay, so that is where my 75 would end, right here. That's my point, where my 75 would end. All right, and what I need to do now is I need to, now I've established that, I'm going to put in. So this is where my omega angle would be. So I'm just going to copy my 60 degrees X over here. And let's just take off my ortho for the time being and stick it right there. Good. And now change that text to 75.78, 75.78 degrees. Now, I don't think I need this screen over here with the instructions because I have actually set it the configuration. So now we can start to plot this. So what's the first thing we're gonna do? Let's trim some of these lines that we don't need anymore. But before let me explode this group. Explode. Explode, what does explode mean? Explode just means to dissolve a group. So I no longer have these two lines as a group anymore, or a block. Block is probably the better term. I have them now exploded, so they're now once again individual lines. The reason being is I no longer needed those. Those were just reference points. So I can, while I'm cleaning up my drawing, I have my angle in and just like that. I no longer need those extra reference points, right? And just match drop there. That's my angle line, and that's my rolling circle. So let me just trim this. TR is the shortcut for trim. And I select everything, and I just have exactly what I need. So my circle is going to move from this point, which I can call my A, and call down here B. Yeah, that will make lots of sense to call here A, and call down there B. Right. First, I need to divide my circle into 12 pieces. And then I'm going to divide this line here into 12 pieces also. But first, let's start with the circle. So the shortcut is div, enter, select the circle, that's 12. And those are my 12 pieces. I don't like the size of my point style. So I'm going to change my point style to actually, for this one, 2. I'm going to put it as circle and X combination. Yeah. reason I changed it to 2 is because I want it to be very fine as I'm actually working here. I don't want my point style to be too big so it wouldn't get in my way. So I'm going to, now I've divided the circle and I see where the points are. I'm going to draw the lines to actually show the divisions of the circle. Okay, good. I've done that. Now, what I need to do now is create radial lines from this point here. Let's call down here point C, so that while I'm referencing points on the drawing, we know where I am at all times. Right, so I'm at point C and I need to make radial lines of the base circle at these different intersecting points around the rolling circle that has been divided. So how do I do that? Hit C for circle, enter, and this is where the axis of my circle is, and I open it to each one of these points. But because this is a circle, once I open it to these 2 points, to this 1 point here that I have highlighted, it would also open apart, and it will also touch this point. And respectively, when I get to this point, it would also touch that point. So let's watch this process as I draw. So I snap it to that point, and I snap it to this point here, and I snap it to this point here, snap it to up here, and then I snap it to the top division of the circle. All right. I need to extend this line, and I'm going to extend this line so it touches there. Okay, so what I am going to do, clean this up as we go. I no longer need all of these points, all these circles. I just need arcs. And I have cleaned up my drawing, leaving exactly what I need to finish my construction. So I have all of my lines in except one line. And I'm going to go over to center, my center layer. And I'm going to hit C for circle and start my circle at point C, and then make it interact with the axis of my rolling circle. That is a very important line. That's my center layer, that's my center line, and that's the line that my circle is going to be rolling on. So now that I have in that circle, I'm going to actually just trim it so that I only have exactly what I need. That's what I need here. So this is my center layer. This is the axis line or the axis curve that this rolling circle will be traveling on. So this is the traveling circle. I'm now going to divide this into 12 pieces. Div is a shortcut. Enter. Select the line. Touch. 112. Enter. These are my 12 points here. Now I'm going to move from my center layer back to my construction layer, and at each of these points I'm going to draw a line from each one of these points back down to C. Yeah. Straight line from each point back down to C. If you guys watch my cycloid construction video, you will see that this is quite similar to the cycloid construction. In the cycloid construction, you have to have 12. There's a division. The number 12 comes up twice. Dividing the circle and then dividing also the path that the circle, the rolling circle goes through between points A and B. Or I think in that one it's points A and P. The one thing you know about cycloids and epicycloids, and then there's the final one called a hypocycloid. You always have to divide the path, and you also have to divide the rolling circle. Okay, now what I need to do is I need to extend each of these 12 lines here to the last arc or last curve here. So what am I going to do? Use the shortcut EX to extend. The word extend comes up, enter. I'm just going to grab all of these lines here. Then I'm just going to also grab this back line so that that's the point I want to extend my lines to. Once I have them selected, hit enter, and then I'm just going to go back over. Once I go back over each one of these, you will see it just shoot out to that back line. Okay, good. I could trim this point here because we no longer need this extended all again. All right. So at this stage, what I'm going to do is put in some numbers. I'm going to number the points on my circle. Actually, some people don't even bother to create a full circle. Some people create a semicircle, a half circle, so it doesn't confuse them. I think I'm going to do that. So I'm just going to trim circle there and there. And I'm just going to take out that. And some people and why did I do that? So it's to simplify the drawing. That's all. I made that move to simplify my drawing. So I'm going to put my circle, which is the rolling circle, I'm going to put it in my outline layer. All right. Okay, good. So I need to now label my stuff here. I'm going to go over to my text layer, M key, to bring my M text. This is my point 0. What I'm going to do is copy 0 12 times and then just go back and edit. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to go edit. 1, 2, 3, 4, 5, 6, 7, 8, 9. Some students tell me that this is perhaps the most boring thing to do in AutoCAD, to actually be labeling and numbering and putting down the correct information. But I always encourage my students to label, number, and set up a proper title block. And if you think you're going to forget, add some notes to the sheet also. So that whatever you need to do to remember the process, do it. And I think that numbering my points, numbering where I need to number, placing points, join with these different layers, I think all this helps to make you as a viewer see this thing clearer. Okay, so let me just now get back. I'm going to label, I'm going to number this semicircle. And the way I'm going to do that is I am going to copy 0 and place it up here. So this will be my 12, my 11, this will be my 10, this will be my 9, 8, 7, 6. But there are two ways how I can number the circle. Because I have removed the other half of the circle, that means some places share 2 points. So 12 is a standalone spot, but 11 goes with 1. So that's 11, 1. Let's just say that. This one is 10, 10, 2. So this line would have gone through points 2, and this line would have gone through points 1 had I not removed the other half of the circle. So that's why I'm labeling it like this, so that you guys would understand. That's 9 and 3. This is what now? 8 and 4. And this is 7 and 5. Yeah. And then this last one here will be 6, which is a standalone. You can't really see my 6 because it's sharing the same spot as A. All right, now I think we are all ready to plot our curve. So let's just recap what we have here. We are actually trying to find um, the epicycloid as this rolling circle, which is radius 20, rolls on the base circle radius 95. The angle that we had to orient this is angle 60, but the omega angle that we used to determine the path or the circumference or the distance it would have to travel from A to B is 75.78 degrees. Okay, so let us now, I'm going to maximize the screen again, and I'm going to jump back over onto my outline layer. And this is where I'm going to be creating a circle. So first I'm going to create a circle, and my circle is, yeah, that size, which is radius 20, and I'm going to move it. So I'm going to move it to point 1 and see what happens. So every time I go down this number line, go through these different points, this is the axis of the circle. So the axis needs to move from 0 all the way down to 12. But every time I move down the line, I need to also go up this. I need to go up on the arc lines. So I start off my circle at A. So that's why A is right here. So this is actually my first point to creating my epicycloid. This is point 0, or this is my first point of my curve, which is on the baseline. So where the baseline interacts the circle, which is here. Now as I move from 0 to 1, the circle has gone in one space, so it needs to go up one space. So that means that I'm now looking for the point where the circle interacts or intersects with the line 7 and 6. So here, there's a point. Now I'm going to move my circle from 1 to 2, and I'm going to look for where 2 interacts or intersects the line 8 and 4, which is right here. That's where I place my point. Now I'm going to move my circle from 2 to 3. And again, I'm looking for what happens at 9 and 3, which is right here. There's my point. Move my circle from 3 to 4. And I'm looking at what happens at lines 10 and 2 as my circle interacts. There. And I move from 4 to 5. We go up to lines 11 and 1. See what happens there. There's a point there. Move it from 5. Circle from 5 to 6. And let's see what happens here. And I'm looking for what happens at this line now. So now we are at the top of the curved lines, or some people call these arcs. So we are at the top, which is number 12. And at the top also represents halfway. As my circle has moved the distance between A and B, we are now halfway, which is at point 6, line here, point 6. And this is where point 6 interacts, line 12, right here at the top. So similarly to the cycloid, the halfway point always interacts the top line or the top arc. And then we just go back down the curve now. So we are going from 6, moving the circle to 7, or moving the wheel, as some people would say. And we are looking for the point here where the circle interacts with now 11 and 1. Now we're moving this circle again over from point 7 to point 8. And what are we looking for? We're looking for where the circle interacts with the line 10 and 2, which is right here. Moving the circle again from 8 to 9. I'm looking for where the circle interacts with the line 9 and 3, which is right here. Moving the circle from 9 to 10. And the line we are looking for is the interaction at 8 and 4, sorry. 8 and 4. Point there. Move the circle from 10 to 11. That's my point here. And move the circle from 11 to 12. And then it interacts. All right, at point B. So now at this stage, I'm going to turn off my construction lines, turn off the bulb, and I'm also going to turn off my text. So what do I have? I have my epicycloid here all in points. Right there for me to see. And this is where I'm going to draw my spleen now. SPL is the shortcut for spleen. I start there, there, and I go to each point. At the end of your spline, hit enter. That's how you close it. So that is my epicycloid circle and my epicycloid curve as it makes one rotation. So I'm going to turn back on my construction there and my text that you can see. Yeah. So we have actually solved the problem. And this is what we started off with. Rolling circle, radius 20 millimeter, base circle, radius 95 millimeter, and the angle you're supposed to use to set your instrument to create this angle. The angle is 60. To use your set square or whatever. If you were drawing on a table, you would use that to set up where you would actually start your rolling circle. And the angle, the omega angle, like I call it, which is in here, is 75.78. And how did we get there? This is the formula here, which is 360 degrees multiplied by the rolling circle divided by the base circle. And these are all, the numbers are all given in diameter. So the rolling circle diameter is 40 millimeters. And the base circle diameter is 190 millimeters. So that is the answer to the formula, 75.78. Plug that in, and where it is here. And this is the problem complete. So I hope you guys understood this. Again, if you guys found this a bit challenging, always stop the video and solve that bit that I've just done, and then resume the video, take on another chunk, stop the video, and then solve that, and then resume the video. So it's a series of starting and pausing until you actually get this done. That's what it is, essentially, but the information is all there for you. Again, thanks for joining. If you like this video, please share it with others. Please like and please subscribe to the channel. Thank you.